the different types of asymptotes that we encountered already, vertical and horizontal, they're pretty easy. Once you get the equation, it's either a line that goes up and down, vertical, or a line that goes left and right, horizontal. Now we're going to be looking at asymptotes that are slanted. So they have some kind of slope other than 0 or undefined. What's the equation of a line that you know best for slanted lines? Y equals mx plus b. So when we name slant asymptotes, instead of having like x equals a number for vertical, y equals a number for horizontal, it's going to be in the form y equals mx plus b. So this first slide, you don't have to write anything down because this is from your notes yesterday. Everybody should have this down about horizontal asymptotes. To determine the horizontal asymptote, you will compare the degree of the numerator and the denominator. When you compare two numbers, there are basically three things that can happen. Could be less than, could be equal, could be greater than. Yesterday, we talked about really the first two cases. What if my horizontal asymptote was at y equals 0? What if my horizontal asymptote was at y equals a over c? And that should have been all you really encountered on your homework. Today's examples are the third case. What if my numerator's degree is greater than the degree of the denominator and I don't have a horizontal asymptote? In some cases, you will have a slant asymptote. The slant asymptote happens when the degree of the numerator is exactly one more than the degree of the denominator. So that would be in our third case, greater than. So you would only be responsible for finding slant asymptote in that one particular case of greater than. The degree of the numerator is exactly one more than the degree of the denominator. That could be quadratic over linear, cubic over quadratic, quartic over cubic, so on and so on. Okay. In order to find the slant asymptote, I recommend long division. Note that you could technically use synthetic division if it was quadratic over linear, because you can use synthetic division when you have linear divisors. We recommend long division because what if it's cubic over quadratic? Then you're going to need long division in order to be able to get your slant asymptote. The slant asymptote is just the quotient in dividing, so that's like when you're doing long division, it's when you get to the end of that like division box that you create. Anything that has to do with the remainder, ignore it. Okay, so only that little piece that is your quotient, and it should be linear, it'll come in the form mx plus b. That'll be your slant asymptote. So you'll see when we do an example, once I get to the place where it's all going to be remainder stuff, I just ignore it. If you were doing a quadratic divided by a linear and you did synthetic division, then you would just ignore that last number in synthetic. You don't care about it because it's the remainder. Let's do an example. F of x equals negative x squared plus 3x plus 2 divided by x plus 1. Well, this is what I would say. It's still a rational function, so I would do all of the things that I normally do. I'm not really saying change anything about today, because on a quiz or a test, these things are going to be all mixed together, right? How will you know? So, like, I would do all the steps that I did yesterday, just possibly add in a slant asymptote. So what's the first thing I would do? Check for holes by factoring. Yeah, so I would try to factor if possible. Note that I myself never try to factor with a negative leading coefficient. That to me is too difficult. So whenever I have a negative in front of my first term, I always factor out a negative. So that would give me x squared minus 3x minus 2 over x plus 1. I think it's a lot easier to determine if I can factor positive x squared minus 3x minus 2. Do I have factors of negative 2 that add to make negative 3? No, because if they multiply to make negative 2, one is positive and one is negative, and so they would either add to make 1 or negative 1. So that quadratic does not factor, which can't cross anything out. That just means there's not a hole. Again, I'm not going to change anything about what I did yesterday, so once I decide there's no hole, I still want to know what my vertical asymptote is. So for vertical asymptote, x plus 1 equals 0, x equals negative 1. And I'll add that over here on my graph. X equals negative 1. Okay, then I would run through my horizontal asymptote. Now, some people may write this down, and other people, you're just doing the check for horizontal asymptote in your head, right? And running the 3 possible cases, less than, equal, greater than. In this case, you would answer greater than. The degree of the numerator is greater than the degree of the denominator. So I use the abbreviation does not exist. Okay, you can say none, there isn't one, that type of stuff. Just don't say 0, because then I think you mean y equals 0. And then here's this extra piece. If you get to the case of does not exist, go back and take a closer look at the degrees. Is the degree of the numerator exactly 1 more than the degree of the denominator? Yes. So that means I should find a slant asymptote. For the slant asymptote, I said I recommend long division, so I'm going to set up my long division. Negative x squared plus 3x plus 2, and then my divisor was x plus 1. And remember, I only care about my quotient. My quotient in long division, it ends once I put a constant right there. After that, everything else would be part of the remainder. So I only have to get to this moment. So start long division like normal. What do you have to multiply x in the divisor to get negative x squared? A negative x. And then stack it above your x term. Negative x times x is negative x squared. Negative x times 1 is negative x. Remember that you're really subtracting all of that, so these things are really plus. So these cancel out, and then you get 4x. You could bring down your plus 2 here. And you start over. What do I have to multiply the x by in my divisor to get 4x? Plus 4. And at that point, I have the last of my quotient, right? So everything else is going to be remainder. I don't really care about it. I'm not going to keep going. That's my slant asymptote. The slant asymptote is y equals negative x plus 4. It's in the form y equals mx plus b. To graph y equals negative x plus 4, that's an mx plus b form. I usually put my y-intercept first. So my y-intercept is 4. And remember, that's on the y-axis, so I should go up 4. And I'm going to put a little point there, but that point is not for my graph. That point is for my asymptote. To graph the rest of my asymptote, I check my slope. If my slope is negative 1, I'll go over to my y-intercept, and then I go down 1, right one, down one, right one, down one. My low dots are off. My tick marks. Down one, right one. And then I can draw that dotted line that is my slant asymptote. Are we okay with how I graph that? Any questions, concerns? Now, one thing that you'll pay attention to is like, you know, to get a good picture of your graph, you kind of want to see like the middle of your X where the like vertical and the slant asymptote are crossing. So I have a nice chunk like down and on the side, but I have only like this little space right here. So I usually, like in my graphs, I try to extend that a little bit so that I have like a larger X piece to see. Because the graph will still come like it did in two pieces. It'll either be here and here in the small sections or out in the larger pieces. To decide where the graph actually is, I need points. So you can use the table of values. You can also use the X and the Y intercepts. I always like to find those if they're, you know, quick and easy. So y-intercept, I'd plug in 0 for x. All these x terms are going to reduce to 0. It'll just be 2 over 1, which is 2. And I can plot that on the y-axis. For the x-intercept, remember my shortcut is to set my numerator equals to 0, but we decided that we couldn't factor that. That doesn't mean that there aren't x-intercepts. There could be places where it crosses the x-axis, but in order to find them, I would have to do quadratic formula. They're probably irrational because it uses the quadratic formula, and that's like a lot more work than I actually want you to do to find one. So in the case where it's not easy to find the x-intercepts, it's okay if you don't find the x-intercepts. But I'm actually just going to be like, it's not that there aren't x-intercepts, I just don't want to do all that work of the quadratic formula. Way more work than I need to do. I could do a little bit less work by just picking some nicer x's that I can plug into my numerator and my denominator. So I have the point at 0, 2. I might like a couple other points here, like maybe I'll do 1 and 2 for x. Figure out what's happening with the graph right there. The quiz on Monday and the test will be no calculator. So when you're evaluating a rational function, just take it one piece at a time. I'm going to take x equals 1. I'm going to plug it into my numerator. So when I put 1 in, I'm first going to square it. 1 squared is 1. There's a negative out front, so that's actually negative 1. Because the negative is not being squared. Only the x is being squared. It's negative 1 times x squared. So that's negative 1 plus 3, 2, plus 2, 4. So then I write down 4 over, and then I go back and I do 1 plus 1 is 2. So you got to be able to do some mental math. That means I have a point at 1, 2. 1 to the right and 2 left. Next I could do the same thing with 2. 2 squared is 4, negative 4 plus 6 is 2. 2 plus 2 is 4. And you could be writing these things down if you needed to. Okay, to keep track of them. Sometimes it can be easy to lose it. And then 2 plus 1 is 3. So this is 4 over 3. You know, you don't need to really write it as a decimal if you don't want to. I know it's just a little bit more than 1, right? 1 1/3. So I'm going to go right 2, and then I'm going to go a little bit past 1. So now I have 3 points there, but I also know that my graph is kind of constrained by my asymptotes. So I kind of have an idea of what's happening on the left side of my y-intercept. It must be getting really, really close to my vertical asymptote there. Okay, dropping to negative infinity. you have these 2 points that have the same y value, your graph is not just going to turn into a constant function right there. Okay, so you don't connect them with a horizontal line. These are still going to be curves. So it must have gone above that somewhere in between and then turned around.
What is the point at 1 being
No. 1 squared is 1. Negative 1 plus 3 is 2. 2 plus 2 is 4. And then divide by 2. Okay? Now, I kind of know where my other picture of my graph is going to be. It's going to be like sort of like an odd rotational symmetry, although I'm not about the origin. But you should pick a few points, like you could do -2 and -3 and see what you get for those. So -2 squared would be 4, but then it would be negative. So that would be -4 minus 6 is -10, plus 2 is -8. And then in the denominator, -2 plus 1 is -1. So that's like 8. And then I'll do -3. -3 squared is 9. That's really -9. -9 minus 9 is -18. Plus 2 is -16. And then -3 plus 1 is -2. So that's also 8. So that's kind of like what just happened before with our 2 that had the same y value. It's going to dip in between those 2 points. It's never just going to turn into a straight line, horizontal line right there. It's going to be curved. So it's going to approach the asymptotes, dip, and make it curved. This one should probably go closer to the asymptote. It's going to follow the asymptote like that, almost like a V, right? Now, your 2 V's can be right there in those like skinnier pieces. It can also be in the wider one. So then you have like these really big open V's. So you need the points to decide where it belongs. Does anybody have any questions about what we did right there? Now, the last thing is, like sometimes I ask you about domain and range. On these graphs with the slant asymptotes, notice that the range, there's like this big open gap, and in order for you to be able to say what the range would be, you need to know this lowest and highest point, which without a calculator would be kind of hard for you to find the exact value. So I'm only going to ask you about domain if it has a slant asymptote. Okay. Range would not be fair. So what would be the domain? What value or values would I exclude from this domain? -1. That should be the only one I exclude because it's the only one that makes the denominator equal 0, right? Okay. It works everything left of -1. It works on everything right of -1. So -1 is the only thing I would exclude. And again, it's not really fair for me to ask you range unless you could use your graphing calculator and do the min-max. Questions?